So again, problem 14 on page 425. We're asked to find the shaded area. And you see the shaded area is between x equals -1 and x equals 4. So that's why the integral is from -1 to 4. From the above, which is g, which is x plus 28, minus below function, of course, which is f. So minus x to the fourth plus 8x cubed and minus 18x squared. Is this okay so far? Is this okay so far?
Yeah.
Okay, very good, thank you. So this is the integral. I just wanted to arrange it. You don't have to do this, but I prefer arranging in a descending order. So negative x to the fourth plus 8x cubed minus 18x squared plus x plus 28 dx. Okay. So now the antiderivative, negative x to the fifth over 5 plus 8x to the fourth over 4 minus 18 x to the third over 3 plus x squared over 2 plus 28x from -1 to 4. Okay, good. So now, what I want you to do on a test is this. Plug it in, -4 to the fifth over 5 plus 2 times 4 to the fourth minus 6 times 4 to the third plus 16 divided by 2 is 8 plus 28 multiplied by 4 minus parentheses 1/5 plus 2 plus 6 plus 1/2 and minus 28. That's all I want you to write. And then you can write the final answer, calculating all this with a calculator. I don't want you to spend 10 minutes on this. There is no point. Okay? So I'm just going to do just that, like what I just said. Because it takes a lot of time, and you saw that a plus was turned by mistake into a minus and everything collapsed. So -4 to the fifth power divided by 5, and then plus 2 multiplied by 4 to the fourth, and then minus 6 times 4 to the third. I know that is 64, but I wrote it now, so it's okay. And then plus 8, and then plus 28 times 4, and then minus 1 divided by 5, and then minus 8, and then minus 0.5, and then plus 28. And also you can check this 62.5 or 625 divided by 10, and you can simplify if you'd like, or 62 and 1/2. You can also check with this feature, and this is the integral from -1 to 4. Katie, was this the question? Was something difficult with this, or you were not sure about?
I just second guessed myself going through it, so I just wanted to go over it again.
Oh yeah, of course. Negative x to the fourth, and then plus 8x to the third, and then minus 18x squared. Did you check with the calculator?
Yes.
Okay. And did you get this, or did you get something else?
I think I got something else, but that's okay.
Maybe I made an error. Anything is possible. Okay. So it happens that this time I'm okay. 62.5. Good. Anything else you need help with? Anybody? Anyone else tried anything? Should I wait? Anything? Any questions?
Could we go over question 4 on the homework?
Yes, of course. I don't know which page. As you know, I did not get the chance to.
On 5. Page 4 from 5 and 10.
So you said
Or the same page that we just did.
the same page, yes? Which one?
Question 4.
Question 4. This one here?
Yes, ma'am.
Very good. So let's take a look at 4. And we have g of x equals x squared plus 4 for x less than or equal to 0, and 4 minus x for x greater than 0. And the interval is negative 2 to 3. Good. So in order to determine this area, we see that it is broken right at 0, meaning in order to find the area from negative 2 to 3 from g of x dx, I have to find two integrals. One from negative 2 to 0, negative 2 to 0 from x squared plus 4 dx, and the other one from 0 to 3 from 4 minus x dx. Good. So this is x to the third over 3 plus 4x from negative 2 to 0, and plus 4x minus x squared over 2 from 0 to 3. So when I plug in 0, wonderful, everything is 0. Minus, when I plug in negative 2, negative 8/3 minus 8. And plus, when I plug in 3, 12 minus 9/2. Because when I plug in 0 is all 0. So this is 8/3 plus 8 plus 12 minus 9/2. Now, 4 numbers is not difficult to add, and it's not going to take a long time. But these may. Okay. So 8/3 plus 20 minus 9/2. So these common denominator is 6, and 2, and 6, and a 3. 16 minus, plus 120 minus 27. Okay. So 16 plus 120 is 136 minus 27 divided by 6. So this is 109 divided by 6. Of course, you can check with a calculator and see if you get the same thing. Is this okay?
Yeah, I'm sorry. It's good. Thank you.
Thank you. Anything else? Do we have other? Do we have anything else? Okay, so what I wanted to continue with tonight is try to finish chapter 4 with section 4.5. We have many techniques of integration. In this class, we are only going to address one of them. It's called substitution. It's a technique of integration. There are many. And this is one of them. This is basically the easiest of all. Can anyone give us a function, any function, nothing fancy? Because I would like us to determine its derivative again. This is the third time we discussed this. And differential. Can anyone give us a function? Again, nothing fancy. Any function, please. Anyone could make up a function?
X squared minus 3.
Very good. I'm going to put x squared minus 3x. Perfect. Excellent. So can anyone determine the derivative of this function? Can anyone give us the derivative of this function?
3x squared minus 3.
Excellent. Can anyone give us the differential of this function? Please, anyone, the differential? Anyone remembers the differential? What is the formula? What is the notation? We need this for understanding the substitution method. Anyone remembers the differential? What is the formula? Anyone, please?
3x squared minus 3.
What is the notation? What is the formula first?
E over dx.
dy equals f prime of x dx. This is the differential. So now can anyone give us the differential for this function?
Three x squared minus 3 times dx.
I have to start with this. Yes. Indeed, this is it. So you're going to see now why this is extremely, extremely important in this chapter and the last section. That's all we cover in chapter 4, 4.1 through 4.5. Okay. I am going to start with an example, and then we'll discuss the example, and then you can choose anything you want after that. I'll choose the first one. I'm going to choose problem 2 on page 434. We have the integral from 8 plus x cubed to the 5th power times 3x squared dx. Okay, so looking at this example, of course, just to make sure, we're going to use or learn how to apply substitution for two different types of integrals, of course, definite and indefinite. So please pay attention because there is a difference between these two. Of course, they are not the same. The definite is a number, the indefinite is a function or a family of functions. And the substitution is applied slightly differently. So I'm going to start with the indefinite examples. So looking at this example or this problem, obviously this is a differential, is a derivative of a function times dx, like any integral. Okay, now, second thing that I'd like to mention, it's a complicated situation. The function is this that we're looking at, and it's complicated. It's a binomial raised to the 5th power. So this alone will have 6 terms if I decide to expand it, and then distribute 3x squared to those 6 terms. No, we're not going to do that. Instead, we're going to analyze these two pieces and say, which of these two pieces is more complicated? Is it this? I know it's a silly question, but follow me, please. Is it this that is more complicated, or is this that is more complicated? What do you think? The first piece or the second piece?
The first piece.
Of course, absolutely. So I'm going to say let any letter except x. You can use any letter you like. Let's say let y be this 8 plus x cubed. So this is my substitution. I want to denote this piece by y, but I need a differential. Can anyone identify or determine the differential of this function for us? Can anyone find the differential for this function? Initially, we had x cubed minus 3x. Now we have a different, yes,
dy equals 8 plus 3x.
when we differentiate 8, we get 0.
Oh, so no, it would be 3x squared multiplied by dx.
That's it. This is how I know, and this is when I know that my substitution is a good one, is the appropriate one. There may be more appropriate substitutions in different examples, but I know that this one is a good one. Here's why. And the answer is right here. This is my dy. And this is y to the 5th. So I am replacing this integral by, jump over all this, the indefinite integral from y to the 5th dy. With this very simple substitution, I changed an integral that looked horrible, terrible to work with, into something that is extremely easy. So when I integrate, or I find the indefinite integral of this, I get y to the 6 over 6 plus a constant c. I must go back to the substitution. Why? Because the integral is given in x, the answer has to be given in x variable. So what I have to do is just replace y by 8 plus x to the 3rd, put the power 6 over 6 plus a constant c, and it's done. But the substitution helped a lot. Without the substitution, I may have not been able to come up with this. But the substitution made a complicated situation into an extremely simple one. As long as the substitution I pick has the dy in the problem, I can make up a constant. I can multiply and divide by 10, multiply and divide by 5, but I cannot make up x squared. But it happened that when we chose the substitution and determined dy, we realized that dy was in the problem. Any questions on this problem before we choose the next 10?